So here is example 5. In this example 5, we are asked to determine the surface reaction under block A. This is our block A, which weighs 500 Newton. So it has a self weight of 500 Newton. Also determine tension in the cable. We can see that this block has been attached with a cable over to the top point. So here we are also asked to determine the tension in this cable. So as this surface is an inclined one, the body will tend to fall down from this surface in this direction, but this cable is attaching the body towards to upward, so it will be having a tension on this cable. And now we are asked to calculate the tension in this cable and also the surface reaction that is being acting on this body. So how the surface reaction arises? We know that where there will be a contact surface, there will be a surface reaction, and here we can see this is an inclined plane, and as the plane is an inclined one, the surface reaction will also be inclined. That means directly perpendicular to this contact surface or contact plane. This is our surface reaction. Let's denote it with R1. We are denoting it with R1, and as this is an inclined one, this surface is an inclined one, and the angle of inclination of this surface is 40 degree with the horizontal surface. So this R1, which is actually our surface reaction, will be acting at an angle of 40 degree with the vertical axis. This angle will be 40 degree. We had already gone through this concept in our previous example. If you want to need the explanation, you can go back to the previous lecture. Now we also know that as the body is being fixed with a tension cable, it will be having a reaction force over there. So let's denote it with T, tension reaction acting on this cable. So T, we have denoted it over here. Now in our previous examples, we used to set the global coordinate as the straight one. We used to set the global coordinate at the straight ones, like this was x, this was x prime, which is actually the negative side of x, this was y, and this was y prime. That means y is positive upward and negative in downward direction. Now for this case, so for our benefit, we will be setting this global coordinate. For our benefit or for our interest, we will be setting this global coordinate inclined one. So we have just inclined, so we have set the global coordinate in this manner. So this is x in prime, this is y, and this is y prime. So here we can see that this R1 reaction or surface reaction is coinciding with the y prime. That means it will not be having any component for x direction. On the other hand, we have other reactions like the self weight. You can see here the self weight is given in this question as 500 Newton, which will be acting directly downward. So this 500 Newton is acting directly downward. 500 Newton, 500. So as we have set our coordinate in this manner, so according to our coordinate, this 500 Newton is an inclined one, which is at an angle of 40 degree with y-axis. So this 500 will be having a component in x direction and in y direction also. So as the angle is 40, the y component will be 500 cos 40 and the x component will be 500 sin 40. So let's write it here, 500 sin 40, and this is 500 cos 40. So in total, this is our free body diagram. We can see here that the tension is acting over here for this tension cable. 500 Newton load is acting downward as the self weight, and this 500 Newton load will be having two components as well. One is in x direction and one will be in y direction. And here is our surface reaction R1. Now writing the values of components, 500, this is sin 40, and this is 500 cos 40. After drawing this free body diagram and denoting all the surface reactions and other forces and self weights as well, we will be applying the criteria of equilibrium, which is summation of f of x equal to 0 and summation of f of y equal to 0. So applying summation of f of x equal to 0 in this free body diagram of block A, we will get the values as, firstly, T is acting as an x directional force in coinciding with the x axis. So T is acting in the direction of positive, that means T is acting in positive direction, so this is plus T. And then as the x directional force, we will be getting also 500 sin 40, which is also coinciding with the x-axis, but this time this is acting in negative direction, so it will be minus 500 sin 40. So from here we will get the value of T as 321.4 Newton, which is actually the value of tension in this tension cable through which the body has been attached, Then now applying summation of f of y equal to 0, we will get another equation available. So now while taking the summation of the forces in y direction, starting with 500 cos 40, we can see that 500 cos 40 is acting downward, so it will be minus 500 cos 40. And then we have here this R1, here. R1 is acting upward. This is actually the surface reaction, so R1 as positive will be equal to 0. From here we'll get the value of R1. So these were the things that we were asked to determine in this question. Now here is our example 6, which is almost same, but in this case there are two bodies. We can see over here body A and body B, two blocks actually. So two blocks has been resting on two inclined planes. The angle is given for one plane, for other plane it has been denoted with theta. We need to determine the angle theta as our first question. And here we can see that two blocks are connected with cable over this pulley, and it has been mentioned that this pulley is a frictionless pulley, so there will be no friction, there will be no losses for friction. Now in our first question we are asked to determine the angle theta for this plane. In our second question we are asked to determine the surface reactions under both blocks. You can see that there is a contact surface, and here is also a contact surface for block B. So surface reaction will arise here. Let's denote it with R1. You can see here R1, and for B let's denote it with R2. This is R2. Now for this example also, we will set the global coordinate at an inclined one. Now firstly, setting the global coordinate as inclined one. So it has been shortly written over here, x and y. That means x is positive rightward and x is negative down leftward, y is positive upward, y is negative downward. So here we can see surface reaction R1 for block A. We are drawing the diagram. The body has been attached, the block has been attached with this tension cable T, so there will be a tensile force T. This is our surface reaction R1, and then we also have self weight for block A, which is 500 Newton. So this 500 Newton will be acting directly downward. We know that self weight always acts perpendicular downward. So this 500 Newton is acting here, and this 500 Newton is acting at an angle of 40 degree. Why this angle is 40 degree? Because we have already learned the concept in our example 1 and 2, that in example 2 mainly, as this plane is at an angle of 40 degree with the horizontal axis, so this 500 Newton will also be acting at an angle of 40 degree with the vertical axis. So as this is a vertical axis, this angle will be 40 degree, 500 Newton. So due to this 500 Newton acting at an angle of 40 degree, it will be having two force components. So firstly, this force component in x direction will be 500 sine 40, and as this angle is 40 degree, component in y direction will be 500 cos 40 degree. So this is our free body diagram for block A. We can see that the forces which has been represented over here are tensile force T for the tension cable, R1, which is surface reaction R1 acting over here for the contact surface. We can see the 500 Newton for self weight, and we have divided it into two components, 500 sine 40 and 500 cos 40. Now applying summation of f of x equal to 0 in block A, we can get the values as T is acting rightward, so positive T. 500 sine 40 is acting leftward, so minus 500 sine 40. From here we'll get the value of T. Now applying summation of Fy over this block A, on this block A, we can see that 500 cos 40 is acting downward, so minus 500 cos 40, and R1 is acting upward, so plus R1. From here we'll get the value of R1 also. Now let's draw the free body diagram of block B. Here we can see that the angle is theta, so the angle of R2 with the vertical axis will also be theta, so denoting with theta, so we have denoted it with theta. Moreover, we are having a tensile force for this tension cable T, so denoting it with T. We can see that in our question the self weight is given as 400 Newton for block B, which will be acting perpendicularly downward, 400. So 400 we have written here. Now for this block B also, we will be set our global coordinate at an angle, or at an angle of, with an angle of inclination. So this time the angle will be theta. Let's consider it as theta. Now initially it should be like this one, but as we are setting the global coordinate at an angle of theta, now we can rotate this global coordinate at an angle of theta. That means this will be our y-axis. Let's draw it with black colored. Y-axis, this is y, so this will be y and this will be y prime. This is negative side downward, and this will be our x-axis. This is x positive and this is x negative. Let's erase the red color one. Now considering this global coordinate, newly set global coordinate, we can see that this T, tensile force, is acting or coinciding with the x-axis, but it is acting in negative direction of x-axis. X is positive over here in right direction, so negative in y direction, so this will be minus T. While considering summation of f of x equal to 0, this will be minus T, and we can see that this 400 Newton is acting downward at an angle of theta. So this 400 Newton will be having two force components. One will be in x direction, one will be in y direction. So here the value of x directional force component 400 sine theta, and for y directional force component it will be 400 cos theta. So as we are considering summation of f of x equal to 0, so 400 sine theta is acting in positive direction of x-axis, so it will be plus 400 sine theta. And from this equation, if we change the side, so from this equation we will get the value of theta. How will you get the value of theta? Just plugging the value of t over here, this t over here, then we will get the value of theta as 53.46 degree. So we have already calculated the angle theta equal to will be 53.46 degree. This was our first question. And then now applying summation of f of y equal to 0 for free body diagram B, for free body diagram of block B, in white as the y directional forces, we can see 400 cos theta over here, which is acting downward. This was y positive, which is upward, and 400 cos theta is acting downward, so minus 400 cos theta. We can see that R2 is acting upward direction and coinciding with the y-axis, so it will be positive R2. From here we will, from this equation, in this equation we will plug the value of theta. Plugging the value of theta over here, we will get the value of R2. So in this way we can calculate the tension available in this cable. We can calculate the surface reaction R1 and R2, and also the angle of inclination for block B, plane of block B, theta equal to, which was theta equal to 53.46 degree. So this was all for this lecture. Thank you.